everyone here. So maybe we will start. We'll start this session. I want to start this session by telling all of you that I'm really impressed at all the beautiful code that you are writing. It has been a pleasure to go through them. I have tried. I have been a little bit slow in getting all of you the feedback, okay? Because it's just a lot, and I honestly don't just type something. I actually run your code and look at it, etc. One thing I will say now, I will repeat this again later, is that please do add a couple of comments about how you are thinking about the code, questions that you came up with, or just how easy or hard it was. Some of you do that already, so keep doing that. If you don't do that, then just add a few comments. Start with 1 or 2 lines, and then. So anyway, I have tried to cover most of you with, and most of your work. Last night I was working late, and some of you are still submitting. Every time I was sending back a comment, there was something else to be done. Some of you work late, or some of you at different time zones. I'm not sure. But anyway, keep up the excellent work. Okay. So let's go today and start. I have a lot of beautiful material for us to talk about today. So let me start off by, as always let's do a quick, let me get some feedback from all of you and get warmed up. So how much time did you spend working on Python since last Sunday's class? I'm always curious to know. So can you click on this poll? So I'm on the website. So, okay. I ended up doing more than 3 hours looking at all your code. So let's see what happened. Okay, some of you did more than 3 hours. Okay, this is beautiful, right? And you can think about it, but I will tell you for sure that the more time you put in, the more you're going to get progress and enjoyment, right? Only thing is, don't tire yourself too much. And sometimes when you get stuck with something, don't get stuck for 6 hours trying to fix something, right? It's maybe nice to take a break or even ask for help. But other than that, I think trying to solve problems, working through them, writing code is always a wonderful experience, right? And I cannot simulate that for you. So whatever you're doing there is really, really useful. Does anyone have a comment about your work time, hours? Is it hard? Is it more? Is it less? What, anything?
Kind of.
Kind of what?
So it's kind of like it's kind of so I did the patterns
Yes.
and the shapes,
Yes.
but I wasn't able to do the house because the house was actually pretty hard if you think about it.
Yes, yes. So what we do there is, as I said to you, when you submit, you can, so like some people have submitted just a square, right? That's also a good thing to do, starting with a square. Then, so the point about the house is we have to work at 2 levels, right? At one level, you have to manipulate things like squares and triangles, and then another level, you have to think about the whole image. So what I plan to do is, in the next class, we will talk about how do we organize our thoughts when we have to take on a project that is a little bit bigger than just one square, right? We have to, if you think about everything, we will get confused and it will be very difficult. So we have to break that problem into small steps and then do one step at a time. Okay. So I got the first poll. What about the second one? I'll come back to reviewing. Did you complete and submit any projects? I think most of you, almost all of you have done it, right? So I'm curious to see if anyone did not submit. Yeah, that's 100%. Yeah, I've seen all of you very active. So please keep doing that, okay? And if you need any help or encouragement from me in terms of doing that, just reach out to me, okay? Send me either in your project page, you can put a comment or question, or send me email. Okay, so now we have focused on this session. Quickly, let's spend a minute just reflecting on the things we discussed already. And the way I plan to do this course is, even though we discussed something before, we'll keep reviewing it. Because that's the best way to learn how to program, is to review things and keep them in your memory till it becomes almost something you don't have to think about, okay? So we learned how to use the Python as a calculator. We did some interesting questions. I think all of us can work on creating our own questions, right? And it's not too hard once you start doing it. Think about, for example, I've asked some of you, try to figure out how fast you can run the 100-meter race. Already that's an interesting question, right? So things like that. How long will it take for me to run a marathon? so there's no limit, right? How many pancakes are eaten in America every Sunday? You can ask any kind of question, and then you can find something to work on. Okay, but of course it's nice if the question is interesting to you. Okay, then we learned about using labels to store values. Then we learned about different types of values. We'll keep coming back to these types of values even today a couple of times, but we used integers, we used strings, you have to put quotes to create them, and we started to use floats. We will keep talking about floats. Okay, I'll give you more and more information on floats and why do we call them floats. Okay, does anybody have that question, why we call them floats? What's floating about it?
I think it is because it floats between two digits. It's neither, if we talk about 2.58, so it's neither 2 and not 3. So it floats between the two digits, two
Yeah,
numbers.
but it's kind of a good answer, very good answer. But like when you write 2.8 on your notebook, do you think 2.8 is floating there? It's 2.8. It's not floating anywhere, right? Interesting, right? So, okay, so next time we will talk about this, okay? And we should think about this. What is floating about it? Okay, something very interesting. I'll give a hint. It has to do with how 2.8 is represented on a computer. Okay, and we'll spend some time on it. If you're interested, let me know, okay? Then I will put more time in it. If it's not so important, then we can just learn it as a float and it has decimals in it, okay? We'll come back again to this topic. Okay, then once we have multiple types, we need to go how to go from one to the other. We learned how to use a print function. We're going to keep coming back to the print function as well. And today I'm going to show you a sibling of the print function, which is input. And then we did a little bit with for loops, and we did, all of you did a lot of good projects on writing pictures and images, and we had fun with that. So that was quite a lot actually. And we have really covered a lot of territory. So today I'm going to give you another beautiful set of superpowers. And the superpowers that we want to use, before I get into the superpowers, let me get through some small things, okay? But I'll tell you what we want to do. We want to talk about this topic of how do we get logic onto the computer? Because as humans, we use logic to decide all kinds of things, right? We say that, I don't know, I'll give you some examples as we go along, but you can start thinking about this, right? Do we use logic? I never studied logic in a math class. Do we use some kind of logic? How does it work? What is logic? All these questions should start coming into your mind, right? Then once we understand how we think about it as humans, we can ask, how do we put it on the computer? Okay, and that's what we're going to look at today. Very interesting subject. I wanted to do some demos about organizing your programs, but I don't know if we will get, because this topic is fairly big, we probably may finish off with this. Okay, if I get some time, I will write some code and show you. For example, we can build that house picture together and we can talk about it. Okay, but if it doesn't fit today, we'll cover it next time. Okay, so before I go into today's discussion, which is about how to put logic on a computer and use it to solve problems and in my code, then we had talked briefly about a few things, and I thought I'll collect a few extra capabilities for us today. Okay, so let me start with this trinket here. Is the font okay, or is probably small? Make it bigger. Okay, so the first thing is there is a module called the math module, and I might as well just introduce you to today because we're going to do square roots. And I'm going to say the answer is not to use the math module. We want to understand how does the math module work. What's the real meaning of the square root? But anyway, you can import the math module, and you can say either import math as M. I'm just going to say this, and you should start using one of them. Maybe you just use this for now. There is another way to import. You can say import, or let me just put it here. You can say from math import star. This is how we did the turtle graphics. But you have been very good at absorbing new ideas. So I'll show you this thing as well. You can say this is what we used to do, what we have done for turtle graphics, right? From turtle import star. That's what we did to bring all the turtle functions. Then if I, so let me write one line of code from that old word. So from turtle import star, if I do this, then if I want to use a function like turtle, I used to say things like taco equals turtle, like this, right? So I can say something like this. So this turtle function here lives inside this turtle module. That's how we were working before. So there is another way to do it, right? Which is what I'm trying to show you now. You can say, just like I did here, you can say import turtle as t.
I have a question.
Yes.
So here you said on the 5th line, it says from turtle import star.
Yes.
From turtle, doesn't, actually no, I mean on the 8th line, you have taco equals turtle.
Yes.
With the brackets. Does
Yes.
if the T in turtle is capital, does it make a difference?
Say that one more time. If t what?
If T in turtle, the capital T in turtle, capital, does it
Yes.
make a difference?
Yes, makes a huge difference. So Python in general is case sensitive. Okay. That was Arnav, right, Arnav?
Yes.
Yes, I'm trying to learn all your names and use them, okay? But I know that there's little confusion. Some of you have logged in with your parents' names. So if I'm getting it wrong, just let me know, okay? And if I don't get your name right or don't pronounce it right or anything, just correct me, okay? I'm going to try. There's a lot of names, right? There's about 15 names. I can't learn all of them right away, but I'm going to try. Okay, so the point here is definitely it is case sensitive. So the function is defined. We'll learn about function definitions later. But for now, if the function is defined with a capital T and I try to do this, it will not work. And in particular, notice that because this function is defined with a capital T, all modules are defined with lowercase t. Okay, so there is some important detail here, which is case sensitivity. We have to keep in mind always. Now, the next thing I want to say is this turtle function, we don't know where it's coming from, right? After we did this line, it just came into my program and now I can use it. So that may be enough. That may be all you need to know. If you want to control it a little more, you can say import turtle as t, but now I have to say t.turtle. This tells me where turtle is coming from. Why are we talking about this today? Because there is a math library now. And if I say from math import star, all the math functions will come into my program. Now I won't know, suppose I use a function which we're going to use like round, for example. I won't know whether round came from the math function, math package or from the turtle package, right? So eventually when we start bringing in a lot of things, we won't know who came from where. And sometimes if we forget to do the import, we won't know that we need to import something. So a little bit of chaos can start to happen. So as you get advanced, it's always better to use always like this way, import turtle as t and then do t.turtle. But because you're starting right now and you have only a couple of libraries, I don't mind if you don't do it.
Can we write any alphabet letter? Like
Any
can we write
letter.
import? Okay,
Correct.
import it in the summer.
Any letter, right? Don't make it too confusing. And usually we use 1 or 2 letters because we don't want to keep typing all that stuff, right? So you can even import math as math, right? But then every time you want to use something, you'll say math dot blah, blah, blah. Okay. So having said that, that is for a little bit more advanced usage, but I see that it's going to come to us down the corner. So we'll just take off these two, okay? For now, just to keep my screen clear, we'll just import stars, okay? Just know, but you now in your mind, you should know who's giving me which capability, right? So now, for example, I'm saying round actually comes from Python, okay? And floor actually comes from the math library. So now you see, that's why it was important for us to know what is coming from where. But now we don't have this M anymore in our code, so we can just write like this. So now let me go back and start with, we don't need taco anymore. So I'm going to first start with, last time we talked briefly about rounding things. We still haven't talked about floating points, but for example, if I want to print, so let's start by just printing 4 by 3. So if I do 4 by 3, it's going to print and you're going to get some, oops, M is not defined somewhere below, okay. Notice that code often breaks, but we should just calmly go and look at it and see what's going on, right? So, okay, so let's look at what I did. This is the first line I printed out. I assume that some of you can check that 4 by 3 is something like this. But notice it's a recurring decimal, right? And so we might want to round it to some number of decimal places. Some of you have asked this question before, so today we'll just briefly discuss it. So you do round 4 by 3 and you tell how many decimal places you want. So take some time, make your own decimal numbers. You can put anything. They don't have to be even recurring, right? You could just write here round 3.95 or something and then say round it, right? Or whatever, it will do something. See 43.95. And then you can learn by exploring here. You can put 43.96 or 43.91 and see whether anything changes. Okay. It takes a little time to think this through, but play with it. If you need it, use it. Okay. Next thing is there are also these things where sometimes, so we started, I showed you last time and said, just make it an integer. So if you take 4 by 3 and make it an integer, it will take off all the decimal places and it's a specific kind of rounding, right? And what it does is, if you want to be more controlled, you can say floor or ceiling. So these are all kind of siblings of round, right? They do things, they cut off numbers. Floor rounds it to the lower side, ceiling takes it to the top side. Okay, again, just play with this. And now today we're going to discuss square roots. So I might as well use the math module, and math module has square roots in it. So if you run it, you can see square root of 4 is 2 and square root of 2 is some number like this. And what we are asking is, if I don't use the module, if I just have, you know, variables and labels and for loops and things like this, which I know, how can I write a program that will calculate these numbers? That seems pretty interesting, right? But why are we doing this? I'm asking us to do this for two reasons. One is so we learn what is the meaning of square root. Two is so we learn some idea, how can I calculate square root? In fact, how does Python get this number? You're going to find out. That's going to be a very interesting question. And third is we get to practice writing some code as well, right? So a lot of interesting things from just trying out. Okay, before I start our topic, main topic for today, one last thing which we can include here is how can I get input from the users? Now, some of you have already done this concept, but let's just do it together now. So if I want to get anything from the user, there's a beautiful function, it's called input. And input takes a message. This message can be any message you want. So for example, let me do please enter it. Actually, okay, first let me do a simple one. Let me not do this. Let me do a simple one. Let's get a name. So I can say input, and then here I can say please. Notice I always try to be very polite when I'm writing input messages to my users, right? Please enter a name or your name, we can say. So it's very important, even at this early stage, to think about what my user will experience when they see this. It is one of the places where software developers who can write code struggle because they don't spend enough time thinking about what the user, because the user is an important part of my program, right? He's going to drive the program. He's going to give all the ideas to my program. So if my program does not know which question to ask and how to ask the question, the user will just walk away and not work with my program. Okay, but here right now we're just using politeness. Later, this actually what message I should use also becomes important. And we should use a message here that prevents the user from making mistakes. Okay, we won't get into that whole discussion, but we'll get there at some point. Okay, so now I got this thing. Input always takes whatever the user types and gives it to me. So in particular, I put a label to it. So now name contains whatever the user is going to type, and I can manipulate it now. For example, I can print it out, right? So I can say print name. So what will happen? So let's ask, somebody can answer this. What will happen if I run this program?
First, it will ask for the name, for your name, and after that, it will ultimately print that name.
Yeah, okay, it'll ask for the name. So ask means, will it speak to me or what will it do?
So it will ask you to give an input, and the question is please enter a name.
But it will come on
Display that message. Please enter your name.
Yeah.
It will put a message or it will talk to me?
Yes.
Just a message, right? But okay, later I'll show you that it's very easy to include libraries. Not yet, okay, maybe not even in this course, but it's not very hard to use a library that will actually talk to the user, and when the user speaks something, it will get it from the voice and put it into my program. Okay, so same idea. This is just input from the command line, from the screen. Okay, so let's run it first. Very important thing for you to all to remember. As soon as I run it, it goes here, and the program, you look at the program here, it is stopped. The program cannot move forward right now until the user does something. So when you start writing these codes with input in it, you're going to find once in a way, you're like, my program is not running, what's going on, right? Then you have to remember, oh, I sent input somewhere and nothing has been typed in. The program is waiting for the input. So nothing's going to happen until somebody goes and types something. And the clue you can use is that here it's just blocked. It says stop and it's just blocked. right? So the only way to unblock this thing is to go here, and you see when you click here, it starts blinking. That's another problem. If you clicked on this window and you try to enter some name, it's going to be typing here, right? It's not typing where I want it to type. So that also is a problem. So now anyway, we understood the two problems. You click here now, and I can type my name, VJ. And if I hit enter, boom, the rest of the program runs, right? It prints my name. I could have put it in a loop and printed it 5 times, or I could have done all kinds of things, right?
Why won't you like write string and then write the name part?
Where?
Like print
Inside the
and
print?
then yeah.
Yeah. Okay, so this is Suhani, right?
Yes.
Yes, okay. First time I get to use the name. Okay, so why, but the question is, do I need string? Because what is name? So if I want to ask what kind of thing is name, let's try a trick here. Let's say print, and we'll say type, which says what is the type of name, and tell Python, please tell me what is name. And I'm going to have to enter my name again. And it says it's already a string, you see?
Okay, got it.
So I don't
Like
have
if you write, but if you write the number instead of your name, then will it still? Okay, it will still show it fast.
Excellent question, Suhani. So let's try it, right? If I write, of course, users should not put number in. When I ask for name, you shouldn't put a number. But let's say I put a number. If I put 12, you see what happened? It's very important question and very important thing. Initially, it's a source of many bugs. The user entered 12. Python always, from input, always returns a string. So it took string.
Okay, from input is always a string.
Input is always going to give me a string, right?
Okay.
And so it took.
Why would it just turn automatically into an integer? I mean, it is an integer, so why would it just
Well,
not?
the question is, does the computer really know? Right?
Okay.
The computer doesn't know. It's just some. In fact, we get into another interesting topic. What is this 1 and 2 that we see on the screen, right?
Yeah. Okay.
It has a shape, but how does the computer really know that the shape of 1 means 1 and the shape of A means A, right? It really doesn't know. They're all some kind of character.
Okay.
So to the command, for the command on the line 7,
Yes.
if you add input, if you when he asks you the input, if you write 13.5.
Yes, Arnav. That's where we're going to go, right? So I'm going to show you exactly that one. Okay, so we leave this guy aside for a minute, and I'm going to show you what happens when we change this to a number now, right? That's kind of what you were asking, isn't that right, Arnav? What happens, and then we can put int and so on. Yeah. So first of all, I want to show you what is very surprising. So if I run this program, what do you think will happen? Can somebody try? Somebody else try. I know Janvi and Arnav already gave me answers, so somebody else try.
I don't think it'll turn in. No. Yeah, I don't think it'll turn in. Oh wait, is it just gonna print the number?
Is that Nishant? Hi, Nishant. Okay, yes. Is it going to print? What is it going to do?
It's just gonna. Is it gonna just print the number 5 times? So if you said 1, it would say just 1, 1, 1, 1.
Well, okay, that's a good one. Why would it print it 5 times and not multiply? Suppose I put in the number 2. Why doesn't it say 5 times 2 is 10?
5 times.
Because it's an integer, but it's like now treating it as a string, I think. Because like I remember we did this in the last class.
Yeah.
And you did AB star in like I don't remember exactly, but AB star 5, and it was like AB.
That's right. Okay, so let's just now make just always one thing I want to encourage all of you is it's like a programming thing. We should always run it and stare at it and see what happens. We should also anticipate something. So let's just run it, right? It says please enter a number, and let me say I enter the number 2, and I got something like this. Now we have to ask the question, what would that mean? Why am I seeing 2 so many times? One thing I notice is I see 2 5 times. Yeah. So maybe we can even try another experiment and make this 6 and see if it changes this thing, right? If I do 6 here, what happens? If I say 2 again, I see 2 6 times. So that gives me a clue. And really, what is the clue? So what do we think number is? Right?
I think it means that number. Python thinks that number is not actually a number, but it's an input. I think have a names in it. So that means that it will just print it 6 times because
I mean, it's just It's just treating the number as a string.
Yes, yes, yes. So we're getting there, right? We're getting to this idea. So we have to first ask the question before we even try to come up with an answer. Let us say print, and then we say type. Just make sure. I'll say print type of number, right? And see what does it say. And let's enter the same number 2. And it says what is here is actually a string. So now we have to ask the question, if number was a string, then what happens if you take a string and multiply it 6 times, right?
We need to make it an integer.
Not yet. I am going to make it an integer. But before I do, I'm going to try to understand why is it behaving like this. So let's make the number by hand and make it a string. So how do I make a number which is a string? Well, very easy. You put the quotes around it. So for example, I can make a number like this, right? And if I really have any doubt that is actually a string, I can actually make it by saying, please show me what is the type of this thing. Let's try. And let's see. Now I don't have input or anything to confuse me. I can just stare at it, right? And see what happens. And wow, okay, I should have put in the number 2, which is what we're working with. So let's do this. And we get 6 times 2, right? So now we understand the question. We understand number looks like this. Now the only remaining thing is, what does multiplication mean for characters or strings? And the answer is, multiplication for strings is repetition, right? So how many times I put whatever number I put here, the string will be repeated that many times. And if you think about it a bit more, it kind of makes sense, right? That multiplication, what else can you do with a string? If I ask you to make a multiplication for a string, what can you do? So multiplication for a string is multiply like this. What is addition for a string? Let's ask the question quickly. What would addition do for a string? If I do number plus number?
It will add the
to be
both
number
strings.
number. It will be.
So what will I get?
It will print number number.
Yeah, number.
What does it mean, number number? What I'm going to see on the screen, number number?
So if the number is 2,
Yeah.
it will be 2, 2.
Okay, 2, 2. That is correct. I will see 2, 2, right? It's just going to join them together. So with 2, 2, we don't see so well. So let's make it 2, 3 and see what happens. And you'll see it's 2, 3. So again, we recap. Addition for numbers is just joining, for strings is just joining them together. Multiplication is making that many copies as we need.
If I add a space,
yes, one by one. Yes.
If I add a space after the number, will it like put a space between 2, 3 and 2, 3?
Yeah, it
Because
does.
I remember
It has put a space.
It will
I
add.
tried it.
Yeah, so Python does not know anything about spacing at this moment, right? What it knows is whatever that string is, if the string has multiple spaces in it, for example, if it has spaces, lots of spaces, it will just replicate that whole thing. So spaces are also included. For example, if you run this, you see you get some shape. Right?
Okay, got it.
Right. So literal, it just doesn't know anything more than there's a quote, then there's a bunch of stuff in between, and that's it. I don't know whether it's a space or whatever it is.
Then like if you in line 13 you have brackets, single brackets, and if you put if you do like the you have quotation marks. If you do brackets on them, it will make it integer, right?
Not yet. So now we're getting to the main question. So let's make it back into a sensible looking number. And now say, okay, I have a string, but I don't want a string. Right? I don't want an integer. So what can I do? And the answer is, there is a thing that takes the string and makes an integer. Sorry?
Yeah, it's something like we did last time. We made in the same way we made an integer into a string, and just the opposite of it is making a string into an integer.
Exactly. So for example, let's do that exactly that way. So for example, here now we take the string 2, 3. This is a string. We make it into an integer. So now if I run this program, what will happen? Can anybody tell? Let's pick someone who hasn't already told. Shaurya, why don't you tell me? What do you think?
I think it will 23 plus 23 because you've converted it into an integer.
So what is it? Is it going to say 23 plus 23? Or it's going to say 46?
46.
46. Okay, excellent, Shaurya. That's good. So you see it became 46, which is what we expected. Right now it has become 23 integer. And if you add the integer with 23 with 23, you should get 46.
Can we make this a float by adding float and then brackets? 23.
Here, you can make it a float. So let's see if you make a float, what happens. If I make a float, what should happen, let's see what happens. It becomes a float number. But of course, there's nothing after the decimal point. So it simply puts 0.0.
Can I
Right?
see?
It's clever. So let me try one more thing quickly. 23.5 we can try. And now it will actually do the right thing. It's still 0 because 0.5 plus 0.5 is 1. Yes?
So what if like you write integer and then in the brackets it's actually 2.5, 23.5.
Okay, then it will cut off. If you remember, we talked about this idea. It will cut off and make it 23. So it'll, oops, first of all, it complains. Invalid literal. It doesn't even like it. So that's even better. Right? It says, I
Okay.
don't know how to convert it. Okay. Okay, so this is better.
One
Okay.
question.
I think if you, yeah.
Yeah, it will only work. Integer will only work if it was actually a float 23.5. Okay. If you give it 23.5 like this, then it will work. It says I can cut off and make. But if you give it the string, it says I don't know how to cut it off. What is this? It's some string. There's no natural way to make 23.5 into an integer, into an integer. So
So
only valid things don't have decimals. I don't know what to do with that dot in the string.
I have a question.
Yes.
My question is that if I so instead in 23, if you make the single quotes, like if you put a word there, will it make any difference? Like if you put like happy.
Yeah.
and-
23 happy will definitely break, right? It doesn't even like a dot, then it's certainly not going to like happy. It's not going to be happy with happy. Okay.
Yeah.
But so what is the moral of the story though? The moral of the story is when we manipulate things in life, but particularly in programs, we must know what is the type of thing we are manipulating. And somewhere in the back of our mind, we should always know what is the type of the thing. Is it an integer? Is it a float? Is it a car? Is it a human? Is it a happy human? Is it a sad human? These all can be made into types, right? And we should know how to interact with different types. And as I said before, when we first introduced types represent a collection of properties and behavior. So the better we get at recognizing types and manipulating types, the better we get at writing programs and also for your life. Now, one last thing I will tell you, which is kind of cool, is the fact that I can make a string out of an integer. So we took strings and we made integers. Do we need to do the opposite sometimes, convert integers into strings?
Yeah, when we are taking the input, because it always considers any input as a string. So if we want to, suppose we have inputted age, my age is equal to 10. So if we want to suppose print that 5 times 8, so we'll have to convert it from string to integer in order to get what we want.
Correct. So this is the normal case, right? So whenever you write input, you probably need to convert. And my rule of thumb to all of you is, as soon as you get an input, decide what it has to be. Right? When you get an input, decide, is it a string, is it an integer, and then remember it always. Okay, so now this program will actually work. Please enter a number. Let's see if you enter a number 2 now. Now it actually does whatever, 2 plus 2, we were trying to do 5 times 2. So let's just go back to our 5 times 2 example. 5 times 2. We get hopefully 10. Everything is good. So this part is clear. We got a string, we made it integer, we manipulated it. Now I'm asking a different question. Is there any place, once now I've got an integer in my hand, do I need to make it go back to a string?
Not necessarily.
Not necessarily. Okay, so I'm going to give you an example. So if I want to print a message now, and I say 5 times your age, let's say, so please enter a number of 5 times your number, 5 times the number is, and here I want to put the answer, right? I want to put this 5 times number.
We'll have to convert it into a string again, because it Python cannot concatenate an integer and a string.
That's it, right? So here we have a problem. So let's make the problem happen quickly, then we'll make it go away. So already it complains, it doesn't even run, right? It says I cannot put these together. So suppose I get sophisticated and I say, hey, I'll put a plus and join them. Maybe it will join. Then it goes past this stage. It says, Okay, because Python says 5 times number may be just a string. So maybe this is a string. It doesn't know, so it doesn't break, but it's going to break as soon as we go through the program, because when I put the number 2 in there, it's going to break because now number became an integer.
So maybe you can write 5 times string bracket number.
If I do that, then I will get this 555 222 thing, right? Okay, so let's see. If I put the string here, so notice how all these small things can make some interesting tweaks in our program. If I put the string here, what will happen? Let's see. So if I put the same number 2 in here, I got this, right? So the string actually went to the
We'll
wrong
have to,
place. What we
we'll
need
have to write it before the 5. The
yeah,
whole expression is 5 times number, so we'll have to put the whole expression in bracket and then multiply it by put string it.
correct. So now the idea is that you do the mathematics first. Then when you get the answer, which is 5 times 2 is 10, then you convert it into a string, right? So we have to be very careful where the conversion is done. It's not enough just to know that I need to convert it, right? So let's finish this and we'll say, oh my goodness, this is amazing. So now already all of you should start thinking that how is it possible that people write programs with thousands of these things floating around and the wrong thing is not happening, right? Because the moment you make a mistake like this, something very bad will happen. Let's say we're calculating, how much energy to give to a car or something. And instead of doing, the car speed, instead of saying 2 times 5 and let it go 10 kilometers per hour, you make it into a string 2 and then you multiply by 5 and you get 2002, whatever, 5 2s, whatever, 22,000 or something. And you give that power to the engine somehow. You have a bad thing, right? Very bad thing. So I'm just telling all of you, this is a very important topic, but of course we are here to have fun, so I don't want to make you spend too much energy on it. The best way to handle it is, one, to know the idea. We must always know which type we are manipulating and keep track of it. And two, have some good practice. Like I was saying, as soon as you get an integer, make it an integer. Then leave it as an integer until the last moment when you need it to become a string. And then you convert it the last moment as needed. Okay? So lots of cool things, but now what is the consequence of this? Two, one, we learned about types, but two, more importantly, you now can get any kind of input from user. And so our programs can become more programs that take input from the user. I'll leave you with one tip on this subject. When you're writing the programs, if you write programs with input in it, it's going to make your life a little hard to write the code, because every time it's going to stop like this. And you're going to waste time entering some number here and then pushing enter and so on. So my recommendation to all of you is, when you write a code like this, just make up a number which would be normally entered by the user, right? Make sure it is the correct kind of number. You write number equals 2 here, or if you really want to remember the int conversion, you can even write like this. You pretend that input has already given you something and take off this from my code. So now it's not running anymore. You can write your code, debug it, make sure it's good. And then just in time when you're told to release your code, you take this off and you take out this. Okay, is that clear? Does that make sense? Does that help? So 3 questions. Okay, somebody try to answer. I'll pick on someone. Let me see. Ria, what do you think?
Yeah, I think that helps because then you can see what it will be like.
Right, wonderful, wonderful. Yeah, I think it's working. I'm slowly getting to know all your names. It's lovely. And thank you so much for flipping your microphone on and responding. It's lovely. Okay. And don't hesitate to unmute and ask questions, okay? There are no bad questions here. Anybody asks a question, they help us, they help me also to focus on something, and we might get an interesting discussion.
Excuse me.
Yes.
I just got a question.
Yes. Yes.
Like we are taking out the square root of 2,
yes.
and it is coming in a lot of decimal places.
Yes.
How do we get it till 2 decimal places?
That's why we have round, right? So here, instead of print round 43, you say here, now we already have imported square root. So you say SQRT, and then you do square root of 2. And you say round to 2 decimal places, and let me just run it. Let's see what happens. I don't need this thing again, but here, 1.41. You can see at the bottom, right? And I hope all of you know that's roughly the right answer. So we're going to go and look at square root soon. But does that answer your question, Sanvi?
Yes, sir.
Okay. Okay, so much for this. Now let's go to an, okay, how many people are exhausted from this already? Anyone?
Not much.
Not much. Okay. Hopefully, I try to make it fun. Okay. It can be a very dry subject, but it's not, hopefully not. Okay. Okay. So now this subject is very cool. I hope I also share it to you in a cool way. So the idea is, somebody who is my hero is this person. I put a lot of material here for you to read and have fun. Oh, before I forget, I have to tell you one more thing. I'm sorry to go back. Okay, you know what? Maybe no. Okay, I'll come back. Can you guys remind me? I want to talk to you about the Python cheat sheet and how to get more information on functions. Okay, so one of you has to be like a checker. Okay, at the end of the class, you shouldn't let me go until I tell you that. So let me go forward now. So anyway, George Boole had an amazing idea. He's a very interesting person because he was sitting in a small university somewhere and he got this idea that somehow we should have a mathematical model for human thought, which I think is an amazingly interesting question. And as we talked about, asking interesting questions is really important, right? So this person asked this amazing question, is there mathematics of thought? And what he came back with is something very surprising. He said, if you want to do the mathematics of thought, you don't need to have all of the numbers, integer numbers and decimal places and irrational numbers. You don't need all this stuff. In fact, you should build the mathematics of thought on a very simple idea. You just need two things. You need the building blocks are the concept of something being true and something being false. Okay, so that's a very big idea. Now let's ask this question. What does that sound if somebody came to you and said, hey, I thought about the human thought. You don't need all numbers. You just need true and false. What would you tell him? That's cool or that sounds crazy?
I would say I don't understand even a single word.
That's a good one, Jami. That's the way we should be, right? If we don't understand, we should say, I don't understand. What are you talking about, true and false? What will I do with true and false, right? But now we're going to do that in the class. So hopefully at the end of this conversation, you're going to have some idea, how does this work, okay? So how do we build a whole mathematics with true and false? Well, first, yeah.
Why might it not say maybe?
That is a beautiful question. We still don't know how to do. Maybe is a tricky one. Okay, so let's see. Yeah, somebody said make the font bigger. So let me just do that. Thank you for reminding me. Can you hold that thought, Nishant? Let's get through true and false. Okay, we'll talk about it. It takes us into a very difficult subject. In fact, it's a mildly research subject. Okay. So we'll come. Okay, let's get true and false. Like, hold the question. We'll try to come back to it again. Okay, because I need some language to speak about maybe. Okay, I don't have that language yet. So okay, so just true and false. In our world, we just show it on the screen as true and false. But since we are always about writing code and it's not about some theory, in Python there is these two things called true and false. Notice something very important. They don't have quotes around them, so they are not strings. They're some kind of different animal. And this animal is built based on Boole's idea. So let us check that this is truly a different animal. Let us say print type of A. Does anybody want to guess what will come if I do this?
Class Boolean.
Boolean.
Boolean? Okay, kind of, right? Yes. It actually.
I think it will come that A is true. Oh.
No, it comes. I didn't print it, right? I just said print the type of A. Let's see what happens if I say print A. That would also be interesting. And it says true. Now this is also very important. Python automatically converts this Boolean thing just like an integer. So for example, if I said print 5 here also, let's see what happens. Python automatically, if there's only one thing there, Python automatically converts the integer to a string. So actually Python is little friendly. If it has a chance, it will try to convert for you. You don't have to say, but don't develop this bad practice, okay? If you start doing this, you may get confused, where you put conversions explicitly by hand and sometimes you don't. It's okay, but you better know what you're doing, right? Because sometimes it'll break your program if you don't have in the right place the things. But anyway, what is important for this conversation is, if I give a bool to print, it will make it into a string and it will do something, right? It'll show it to me. So it will show A is true, and if I put B, it will say false, and so on. So it knows how to convert the Boolean into a string. So we got started. And in honor of bool, it is called a bool, right? So that's a beautiful thing. So now we start, how do we build mathematics with things, right? When you build mathematics with something new, the first question we have to ask, we already created the type, it's called bool. Now what operations can be on this type? So George Boole spent some time and said, if I have something like true, does it make sense to say true plus true? Maybe, but I never ever tried to take true and add it with true. What is it? 2 times true? What will I do with 2 times true? I don't do anything with it. So he said, no, the correct thing we want to do with a Boolean variable is to do some logical operation with it, right? So he came up with this idea that there's a logical operation called AND. So now let's try to use, so for example, in English, we say something, right? So you have to keep your English idea in your mind as we do this. If I ask you to print A and B, what should come out?
AB?
But remember, A and B are actually true and false, no?
No, wait, no, okay, they're true and false. Sorry, I forgot.
Yeah. So
Maybe
if you
true,
take,
false?
huh?
True, false?
True.
True, false?
So what is the rule we're trying to
Equal
get?
and false equals to false because, I mean, if
You're saying the right thing?
I don't know how to explain it. If
so
also had false in it, it wouldn't be correct.
okay. So let me come to it. Somebody asked, Arnav asked on why does Python use Boole's idea, and the answer is not just Python. All computers and computer science, and even an entire field of mathematics which deals with logic, uses Boole's idea, right? So he didn't just fix one thing; he fixed a whole class of things. Okay, a big topic, but we'll keep it simple for now. So let's get back to A and B. And the question is, the idea of AND is, if both are true, then it will give true. If one is true and the other is false, then it will give false. Does that match with how we talk in language? You think it matches? So we're going to do an example in a minute. Okay, so let's leave it here. Here's my example, I think. Okay, so let's do this example. Let me make my code bigger. So here's an example. We have a student whose name is Malika. Very special student, and she's happy only if she solves puzzles and writes code. She solves puzzles and writes code. This is English, okay? I've not made a program yet. Now I want to have a program that knows if Malika is happy or not, okay? And you guys are going to help me write such a program. That's kind of cool, right? The computer knows if Malika is happy. So of course the computer needs to ask Malika some questions. You guys already know how to do input, so we're going to do input later. But as I told you, always when you write a program with inputs, you can set the values up. So let's say it's the morning and Malika already solved a problem. She didn't write the code yet. So is she going to be happy? How do we know that? Well, we know that if she solves puzzles and write code, then she's going to be happy. So we just write solve puzzles and write code, right? And then we run it. And it says, no, she's not happy. So the computer says to Malika, looks like you're not happy. Why don't you write some code? She goes and writes some code, and now computer says, did you finish the code? Yeah, I did. And it says, okay, now let me tell you, I'm sure you must be feeling happy. And it became true. Okay, I gave you a simple story here, but see how the AND is working. Is AND working like we would normally use in our logical heads?
Yep.
Kind of, right? Little bit tough concept here. But the difference between our logic and the computer's logic is computer is super precise, right? If it's looking at 2 Boolean variables, only if both are true, it will say it is true. There's only one condition in which this can be true. If both values are true. In all other cases, it will say Malika is not happy. Okay, now we can change this a little bit. I can change my thing. Malika says, you know what, it's maybe suppose some days I only want to do one thing. So I'm going to be happy even if I do only one thing. So now we can change it, and instead of AND, there's another operator now. It's called OR. And OR will work if any one of them is true. Right? So if she didn't write code now, but she solved a puzzle, and you run it, and the computer says, yeah, you're happy. So when is it going to say she's unhappy? Only if both are false. Right? So neither A is true, nor, I don't know if it helps by saying neither. Both are false. So there's only condition in which she's unhappy. If any one of them becomes true, then she becomes happy again. Make sense?
Yeah.
Yeah.
Does it hurt your head, or it's like, yeah, that's normal, that's how I think?
It's simple.
Because I've studied in Java also.
I think it was normal.
Yeah, it's normal, right? Well, that whole thing about Python is really trying to make it simple and also trying to make it look like English, right? It has simple and or and everything like this, right? So it makes it look very much like English for us, right? So it's easy for us to read and manipulate the code. But now you start to see how we can start to write intelligent programs, right? So this was Bull's brilliant idea. First, he said there are two variables, true and false. Then he started creating operators. And what is really cool is Bull also said for most situations, all situations, there are only three operators you need to know. You need to know and, or, and the last one is not. So how does not work? Not works by simply reversing it. So if you take a Boolean variable and apply not to it, if it's true, it becomes false. If it's false, it becomes true. Okay?
But why do we need such thing?
Why do we need such thing? So because sometimes you have to say she's happy if she did not write code. So now how do we do that? Suppose we have a not so good student, and the student is happy only when they don't do any work, right? So then I have to check if she. So let's use only one of the variables right now. So we are this student is happy only when wrote code is false, right? So if I say print wrote code, whatever, if she did not write code, right? So if I say print wrote code, so then it will say is a student happy? If I just say this, it will say even if it's, I don't know, wrote code is true. So if I run this now, it says true, right? But actually the student is unhappy because they did not want to write code. So now you have to say not wrote code, right? And then it will flip. The student is unhappy. That makes my head hurt, this example. I didn't come up with a good one, but you can understand why sometimes you need flip things, right? It's when it's upside down. Okay. So anyway, what is beautiful for all of you to think about is everything we do with logic is built out of these simple building blocks. But we are not yet done. So Bull said one more thing. Okay, so we know how to operate on these variables, but sometimes we need also another idea. I want to make a comparison between things. And in order to compare things, I want to check if two things are equal, if one is greater than the other, one is less than the other. These are the Python symbols for it. But now the question is, let's go and try to use this. But I want to say one important point here. The equals operator, why am I discussing the equals operator in the context of Booleans? So the answer is, what should the equals operator return? If I ask the question, is 3 equal to 5, what should it return? So let's try it here.
False.
Say that
Yeah?
It would say that it's false.
It should say that it's false. But what is that thing? What is that false? That false is a Boolean, right? Okay, so it should say that it's a Boolean, right? So this is a Boolean. So the beautiful thing about all these comparison operators and how to think about it is that they always return Booleans. So that's how they enter into Bull's world, right? Bull said, hey, not only I have Boolean variables, not only I can do and, or, and not on them, but now I can connect it to the rest of the world by making comparisons. And when the comparisons come back, they are Booleans. So you can take multiple comparisons and connect them with ands and ors and all this kind of thing. And if you have all this, I think we're almost done. Actually, it's a rather short story for today. The short story is everything that we want to do, you can do with this. Amazing, right? Would you have believed me if I said this? Are you still believing me?
Yes.
That's pretty big jump of faith, okay? So you're gonna go test this.
How did the Boolean idea get famous?
What, say that again?
How did the Boolean idea get famous?
Actually, I don't know, but I know that a lot of, I have to go and look exactly what was the transfer of the idea, right? But I think what happened is that I think he actually passed away and somebody went and looked at his work. And after his death, they said, hey, there's some interesting writing here about the structure of thought. And then they circulated that book. And a lot of people at that time, this becomes another interesting conversation. I won't do much now. But people started thinking about computing machines. We're talking about the 18th century now, right? And they had no electronics or even electricity wasn't there. And they were already starting to think about computing machines. And they thought that computing machines should be made like mechanical machines, right? So there were people, we will talk about, if you remind me next time or send me a note, we can include a small discussion of that. Okay, very fascinating. People built mechanical computing machines with gears and levers. Think of them like glorified clocks. The technology of that time was like clocks. Actually, there was another very powerful technology. It was the technology of making fabrics, looms. And looms were meant to stitch complex patterns. And so they actually started getting computer-like ideas when making patterns for cloth fabrics. So actually all of you are writing programs to make patterns. You can think, how do they make all these patterns for cloth? Right? Like, are people doing all these things? How do they put it in a mill or something? What happens? How does it all come out? Right? Not just printing on it, but also stitching in shapes, right? So anyway, we'll come to that separately. Maybe someday we can write Python programs to go and stitch patterns into cloth, right? So all interesting ideas. So that's where it came. So then people started saying, oh, Bull has already done all this math and it's very important. And then it just like an avalanche, it took over everything. Short version of that history, okay? So now let's just try to use this comparison operator quickly. I gave a toy example for all of you to see. So a shipping company has multiple items in their catalog, or whatever, people bring things. And they say, look, you can have some number of small items, let's say 2 for now. Oh, sorry, some number of large items, but the total weight should be less than 50 pounds. And you can also put some small items in there. Total weight should be less than 5 pounds. Right? That seems like something only a human can evaluate. You take all these items, you have to calculate, the total weight of each of them, and then you have to join them. And you see this can be written in one line in our Python program, right? So you can already put it in the machine. You can ask the user, please enter the weight of, or you can connect it to a weighing machine and get the weight of the object, right? That's what we would do today. We would have a sensor that can measure the weight of things. People put stuff on the machine, it automatically gets the weight. Then it calculates this stuff, right? And then it tells you whether you're above weight or you're not, right? And it gives back a Boolean. So let's walk through this calculation. You might say this sounds a little strange, but obviously anyone who's tried to ship a package knows that there are restrictions. And anyone who's traveled by airplane knows there's a long queue and people are trying to check in their baggages. And it's all very manual, right? Somebody has to look at the screen, say it's overweight, underweight, calculate something if it's overweight. Many of you have been through this process. But imagine we are good Python programmers. We can go to the airline company and say, hey, we can automate this whole thing. People just walk in, they put the luggage somewhere, there's a sensor, it gets the weight, applies all the rules and tells them if they're good. If they're not good, it calculates what they have to pay. It automatically deducts it from their credit card account. People can just walk in. Nice, right? So we have to be creative. We can use it in a lot of ways. Okay, even a simple example leads us to something interesting. So let's just walk through this. Item A plus item B, Python will just add them. These are two numbers. Notice how I'm using the types. These are two numbers. Python will just add them. Then it uses comparison. And so item A is 10, item B is 20, 10 plus 20 is 30, 30 is less than 40. So what does this part return? Anyone? Just this part. What does it do?
True.
What does it give?
It's true.
It's true.
This condition is true.
Okay. Now what about this part? Item C and item B have to be less than 5. So item C is 2. 2 plus 1 is 3. So what does this part return?
True.
This part returns true. So true and true is?
True.
True. So it's true. So let's try to make this false. Let me put 5 here and see what happens. So now what should happen if I make this 5? What should come out?
False.
False.
False. Okay, so why would it be false? Because this would be true still. I didn't change it. But true and false is false. So it comes up. Very cool, right? Very cool and hopefully very easy. Anyone finding this hard? That's a tough question. Nobody wants to say yes.
No.
No.
Okay, good. Good. Okay, it should be a little painful. Okay, it can be a little painful. It's okay. But you should write a lot of code and then... Okay, I see 2 questions asked to me in the chat. So let me quickly just say, some of you may have some connection problem or something. It's okay if it happens. Just try to see if you can find debug it and fix it for future. Of course, we record all the sessions, right? So after this, I send an email on Monday or Tuesday and let you know that it's recorded. So if there's something you missed, you can always catch up. Okay, and if you need more help, just let me know. Okay, and don't worry too much. And even if you join the session and something is not clear, you can interrupt me. I can repeat something. It's okay. Okay.
You
And then, yes.
You said that you would show us the cheat sheet or something about the cheat
Yeah,
sheet.
yes. I'm going to show you the cheat sheet in a minute. But I also want to show square roots. But maybe we don't have time for square roots. Okay. Let me just. I have two more things before I go to cheat sheet. How many minutes do I have? 5 more minutes.
Yeah.
Yeah, okay. So let me give you one more hard thing and wait on the cheat sheet. So one last thing related to logic. I don't think we'll do square roots today, okay? But it's okay. We covered something carefully so we all understand it, okay? So the next part, in the last part, and the most important part of Boole's thing is also this idea that we can actually have the world organized in such a way that I can branch the world. So I want to draw a picture like this. A Python program is coming from the top and it sees an if statement. And the way to write an if statement is you write if and then you put some condition here. Now, can anybody tell me what is the type of the thing that should be sitting here? Is it an integer? What should be here?
If
It should be a Boolean condition, like
Uh,
it should return to true or false.
It should return whatever, even though it's a complicated thing, at the end of the day, it should become a true or false. Only then.
So this means that it should have Boolean functions in it, like 5 is greater than 7 or something.
Yes,
like that.
exactly.
Okay, then if it's not, then it's say, okay, I do something.
Exactly, Arnav. That's the idea,
Okay.
right? So whatever we put here, even though we didn't think about it before, now you know for sure that it has to end up becoming true or false. Python will try its best to convert it to true or false, even if you give it a string. So later we'll talk about that. What if I give it something which is not obviously true or false? It'll try to convert it. It'll try its best to help you, but sometimes it can go wrong. So now we know about bool. We know that whatever is here has to be either true or false. And the idea is that when the Python program comes, it splits the world into two parts. Only one part gets visited. If it is true, it goes to the left. If it's false, it goes to the right. And so all the code that's inside here, if it's true, only this code will get executed. Sometimes you don't even need an else. Only if it's true, you do something. But in some cases, you need an else. If it's false, then do something else. So the general construction is called an if-else condition, although you can just write only an if. If you just need only one branch in your program, you don't have to write both branches. Okay? But sometimes you have multiple conditions. So then you can put, so the universe now will split into multiple branches. You can have if, elif, notice it's elif, not else if, there's no s there, elif, and elif as many times as you want, and then finally an else. And now our world got very complicated. It's like multiple branches, multiple universes, but only one of those universes will get visited, the one with the condition equals true. All others will get skipped. Okay, so interesting thing. But now you can go back, and this one we can just look at it since we already did this large item, small item thing.
Like what if my if and elif both conditions are true, then like will it do both the things?
It was okay. That's a good question. What is the question again, though? If it breaks, what happens?
No, I'm saying that if like in the if and the elif, like both the conditions are true, will it do both the things?
No, it will never do.
No, it will
do the first one.
will do the first one, that if one, because it will directly get that it's true, so I don't need to move downwards on any of the other conditions.
Okay.
Correct. As soon as it finds one satisfied, then it runs away. Right? It's like a child who wants just one cookie. As soon as they got the cookie, it's done. I'm going to go play. I'm not going to sit hanging out. So Python is like that, right? As soon as it finds one thing, it breaks out. Okay, so you're going to write more code and programs and you're going to see it. But now let's see, how do I use that if statement? For example, the previous example we saw, we put the condition, this whole long condition. But we already checked it gives only true or false. So now my program can be like the baggage program, right? We're already studying, right? We just need to hook it up to a weighing machine and put in the right conditions and we can sell it to the airline, right? So what do we need to do? If this condition is true, then it says condition satisfied or whatever. If it's false, it says condition not satisfied. If you want to write a more clever program, here you can put a calculation of the extra rate if the baggage is more than some amount. So you run this program and it says condition satisfied. You flip this, you make one of them false, and you'll say condition not satisfied. Right? So all kind of easy.
Excuse me.
Yes.
Why did you put the colon after the if statement?
Did I not? I did. No, here's a colon.
Yes. Why did you put the colon?
What does that mean? Isn't there a colon here? Can't you see it?
No. I'm saying why did you put the colon
Oh,
there?
why did I put? Not why didn't I? Okay, so look at the rule I gave you. To write an if statement, you have to write an if statement, then a Boolean condition, and then a colon. This is a Python thing, right? As we know with for loops, you have to put a colon, and then all of the steps of that if statement, whatever happens in this parallel universe, have to be indented by one tab over. And whenever you use tabs, you use the colon with the tabs, right?
So why didn't you put like after the if the item A plus item B is less than and all that thing, all those things in a bracket? Because in
Okay, that is a very good question. Since we're low on time today, I'll not go deep into it. The point is, whenever you have multiple operations, we know this already from mathematics. There is a thing like PEMDAS, right? An operator precedence rule. In Python, I know that Python will do the correct operator precedence rule. That means it will evaluate the plus first, then the less than, then the and, so on and so forth, right?
Okay.
Otherwise, it'll be totally confusing. What is it doing, right? Is it doing 50 and item C? That will be bad, right? So actually, there's implicit brackets here. But I will tell you that if that is confusing and you're not familiar with the precedence rules, in fact, for the first few years when I was writing programs, I hated precedence rules. Now I got very friendly with them. You can just put brackets wherever you think the precedence should be, because brackets, parentheses always wins, right? So I don't care what Python's rule is, I will put my rule. So for example, Python, I want you to not only evaluate the whole thing, I want you to evaluate this part first. Do item A plus item B, then do less than. Okay, so then I put another bracket. You can, of course, you see, you get bracketitis, right? You'll get lots of brackets, but you can force the order, or you can learn Python's order well and then say, you know what, Python will do what I want without the bracket, which is kind of cool, right? Whose head is hurting now after seeing all the brackets? Anyone?
A little bit.
A little bit, I guess.
Should, right? It should. I'm see. Okay, I'll tell one thing, and then we're going to switch out to one last thing, and then we're done with all these Boolean ideas. We're going to write programs. When I write code, because I'm experienced, I can think fast and make it look as though it's easy. It's not my intention, right? It's better to ask all these questions and think about the brackets, and because that's what you might want to do. If you try to follow my path and you don't know the precedence rules, your code might get buggy logic, and then once it gets buggy logic, it's very hard to find a problem once there's a bug, right? Where did I put the and in the wrong place or the plus in the wrong place, etc. Right? So it's okay. Ask these questions and be patient with yourself if anything breaks. So first thing to be sure is things will break. Okay, and of course, make me write brackets if you want to see it that way, etc. Okay, I'll try to explain as carefully as I can. The last thing I wanted to show you is I said there is parallel universes and so on. This you can play with. Okay, this thing actually simulates what happens inside Python. So for example, here you see when it says item A is 10, it actually created, see, inside the mind of Python, a label got created called item A and it has a value 10. Then you say item B is 20, it created. See, this should be in our minds also. When we think about how does Python work, these things we should know. Then it made item C. Does it make something? Yes, it made a label. It put the value 2. Then I asked it to print it and it printed it, right? But it quickly evaluated that whole thing. It doesn't show me how it evaluated, but it evaluated it. Then it has an if statement. So watch this red arrow now. So because it's true, it will go to print condition satisfied. If it's false, it will go to the else part. So it's true. So it went, you see the arrow is inside here, it's going here. And it's going to go here and then it's finished. It doesn't go to the else part at all. So this is something you can play. It's on the website, right? So you can run it and so on. Okay, so this is done. Now quickly, let me tell you about the cheat sheet. So if you go on the course webpage, and here on the right, I updated this cheat sheet. So let me just click on it. It's PDF and it has most of the things you need. Okay, all this greater than, less than, all this stuff. I took a stab at giving you everything you need. Okay, So maybe that comment should be made now. I meant, oops. Okay, one second. Give me 1 second. So the comment is, okay, let me make the comment while I take a second to type this. So the comment is this: I tried to give you all the information you need because I don't want you all searching all over the web to find all kinds of stuff, right? You have the information you need. You try to use the tools that are available, but I don't want to restrict you from searching for things, right? If you want to search for things, it's okay. Just keep track of how much time, because the moment you go on the web and you start searching, you can get lost. You can spend hours and find all kinds of strange things. And in this new world, it's okay to look at other things. It's even okay to copy. I don't like it, because what happens when you copy something from somewhere else is you don't understand it fully. That's the only downside. So if you're ever taking anything, ideas or anything, one is you should give credit to who made it, and two is you should really make sure you understand it. So to avoid all those complexities, it's better you just take a blank screen, use the few tools we have, and then try to build it. And if you still get stuck, then you ask me and then we'll have a discussion, right? And we can always make our world bigger and bigger. Okay. Now, one more thing I wanted to say, just so you have the cheat sheet. A little bit more than that, if you want more information, you can click on this question mark here. If you click on this question mark, it will show you. See, it says modules here. And then if you click, for example, on turtle, it gives you all the turtle functions. Now, again, you can ask me, why didn't I show you this on day one? You'll see the answer is obvious when you start looking at it. One, there's a lot of stuff here. And two, it's really hard to read this to understand what they're saying. But you guys are making a lot of progress. So this is a good time to show you that. Use it carefully. Don't get lost in there.
I couldn't get how you went to this.
Oh, I went too quickly. Yes. So whenever you're working on a trinket, right? Any trinket that you open, any trinket that you're working on in the project page anywhere, if you're working on any trinket here, you just go to this thing called modules. Sorry, I clicked too fast. Here, there's a thing called modules. You click on modules, it'll open in a
Okay, good.
Yeah. Yeah, and there's a lot of stuff. For example, today we saw the math module. If you click, it will tell you all the math functions. But you see what I mean? As soon as I open this Pandora's box, it's long. If you say to yourself, I'm going to try every math function in the math module, you're gone, right? It's gone for an hour at least by the time you understand all these things. But still, I will show you. For example, in math, there's a maths.floor, and it tells you how does it work and so on and so forth, right? So you can go and look at some of these things. I will use this sparingly. I won't try to make all of you run and go there a lot. Okay, I think I ran out of time, so it's good time to wind up. I meant to do this counting on your fingers with you, but now all of you know how to do this because you know the Boolean functions, and you know, for example, some of you have already spotted this pattern that the thumb has a particular type of number that comes on the thumb. Right, and the division, the remainder is with 8. Depending on what the remainder is with 8, you get the answer, right? You get which finger you end up on. So that becomes an interesting big if statement, right? So you're going to go and I don't want to start halfway and stop, but you're going to go and try to write this if statement. And that if statement will help us to figure out where any finger what the answer is. And I'll give one more clue. You don't need a full for loop even here. You can just write.
I have a question.
Yes. Go on.
So does she include thumb again? Like if she does thumb, then index finger, then middle, then ring, then pinky, then ring again, then middle, then index, then like after that thumb. But then when she starts it again, will she include the thumb again?
No, double, just once.
Okay, just once. Okay, thanks.
Okay. Okay. Let me try to update this if you want. I'll update it on the project page. Okay, just make sure. I'll write the pattern. Maybe I should have written the pattern up to 16. Okay. So because you can make up your own rules, right? So I should write it. I will write it up to 16. Okay. Okay. So that was the one, and then now the square root one. Again, so I'm just going to mention it because we don't have time to write. Next class, first thing we will do is we'll write these two programs together, okay? So right now you can do them as part of the assignment. So the important thing is many of you were very clever. You said, oh, you want square root, I'll just import math and do square root. Okay, I'm not even doing that because we did it before. That's not the idea. So the real question is, how will you get the square root of 25, for example? So let's spend 1 minute and ask this question. How would we find it?
You will probably divide it by every number from 1 to 10, and then when the answer would be same as the dividend.
Okay, so that's one way. You can try to divide, right? So for example, if you divide 25 by 5, which is its square root, you get 5. So you can divide by all the numbers and check if you get back the number that you're dividing with. This is one way. The easier thing is just to try multiply, right? You say 1 times 1, right? It doesn't work. Then you try 2 times 2, right? It doesn't work. And 3 times 3 and 4 times 4. And then eventually you get to 5 times 5. And then you get 25 and you're done.
You mean how you just add 1 each time and then multiply to see
That's
if
it. That's it. So let's write this small program. You can clean it up yourself. So you do for I, so this, we are back to for loops now. For I in range, let me put 5 here now. Actually, let me put 6 because I have to go up to 5. And I don't want to start with 0. Okay, it doesn't matter what I start with. Preferably, I should start with 1. Why? 0 times 0 is 0, we know. So we can put this, and then you say print I times I. Right? If I do this, it's going to tell me what is it saying. And you see, you've got 25 here. Let's go one more. Let's go up to 10. We are searching for the answer, so we can go. And you see somewhere here, 25 is the answer. So all I need is an if statement now. So since I know all my Boolean logic, I can say if I times I equals 25. Notice I have to put double equals. This is a Boolean condition now. If this is true, then I'll say found it. I can print I times I, or I can print, okay, found it. Okay, it has to be a
Won't you need quotes?
yeah, sorry. Did I fix my code or no? Yeah. So if I'm checking for 25, I can find it. What about if I want to do for 36?
Wait, quick question. Why
Yes.
are we getting the quotes inside the parentheses?
No, because, okay, I'm cheating. I was being lazy because time was short. I should really do this. Found it, and then we can say the square root. Let's do it properly. Okay, the square root is, and now here I have to say plus stri. Okay, now let's run it and see. All the quotes will be gone. Whatever it should look nice. Okay. So I already gave you some program. It's just not a nice program, right? I just give you sketch to get an idea. And this is how you can work. I talk about organizing programs. The way we can organize programs is just play with it. Let me try to guess the answer. 1 times 1, 2 times 2, 3 times 3. Okay, I make a for loop. I look at the pattern. I need an if statement. I put the if statement. Then I'm almost there. Okay, so some of you have done this. So those who have not done it, go and do it for any number. In fact, you should ask the user, enter a number and find the square root. Okay, but what is tricky, which we should start thinking about, and some of you are more advanced can try to do, is what happens if I put the number 2 in here, right? Because I said I'll give some clues at least. So what happens if I put the number 2? So what's this?
1 times 1.
Huh? So let's see what happens. It won't even, this thing will just not even find anything, right? Should not even find anything, because 1 times 1 is not 2.
That's true.
Right? So the trick here is you have to go in steps that are, because what is the answer? What do we think the answer is for square root of 2? We already saw that from the math library. It's 1.4. So you have to take steps, you take smaller steps, 0.1 size steps, right? So so I've given away the clue and the answer now. You have to take smaller steps. But should I take 0.1 size steps or should I take 0.01 size steps? That's called a precision, right? How accurate I want to be. The more accurate you want to be, the more decimal places you will include in your steps. Does that make sense? So you should draw a number line and visualize this for loop, okay? The first time it's jumping by steps of 1, but we know that the answer square root of 2 lies between 1 and 2. So we have to go in smaller steps than integer steps. So we said we'll go by 0.1 size steps. So we can get up to 1.4. But if I want to get 1.41, then I have to go with 0.01 size steps and so on. Okay, somebody asked this question, why double equals? For comparison operators, look at the comparison operators now. I can use that language. It's a Boolean operator. Equals are signs values. It makes I equals to 2. Double equals is the comparison. It compares and says, is this left hand side equals to the right hand side? Is it true or false? It returns a true or false. Okay. Okay, so anyone feels comfortable that they can write the square root of 2 program?
Yes.
Actually, I tried it before and it wasn't taking any of the decimal float numbers in the for loop.
Okay. So why don't you try it and send me the code and then we'll work on it. Okay.
Okay.
Okay. So I think I don't want to hold all of you long. We had a lot of ideas today that I shared with you. Take your time, digest it, keep writing the code. Some projects are there for you to write code. And the last thing I wanted to say is, when you work on projects, do include a note. Like, it's really important not only to write the program, but to think about what you are experiencing as you go through the program. Next time we'll talk even more about this, right? How we order our thoughts, how we approach the problem, which problems we have getting stuck at. These are all very important. Some of you actually write few sentences. That's very beautiful, okay? But for those who don't write it, start doing it. Start being aware of it and start writing it, right? How hard or easy was it? Did your idea change as you were writing it, right? I thought I could do this and then I did that. You know, do you have ideas how to make this code better? You have no idea. Do you think there's some skill you're missing? Anything that comes to your mind, write a couple of sentences. I don't want to write an essay. Okay? Just write a couple of sentences. Okay, with that said, any more questions?
No.
Everyone's happy, satiated, got a lot of Python today.
Yep.
What do you think? What your someone? So I should pick on someone. Okay, who shall I pick on? Maybe I don't want to pick. Okay, Isaac. Did you like the discussion on booleans?
Yes, it was very interesting and pretty much, in my opinion at least, easy to God, I cannot speak. Easy to digest.
Yes, good. And yes, all of you just, yes, it takes a little time. Don't underestimate it. Don't get scared by it, right? Little by little, it'll become natural. Any other questions from one of you? Somebody asked me a question. There must be some question, no?
I have a quick question.
Yes, Nishan.
Is there anything more to Boolean, or is it just that this is all of Boolean? Or
no, it's not that it's just all of Boolean or not all of Boolean. The idea is that it's like saying, is that all there is? Once I show you the numbers, is that all there is to numbers, right? And the answer is no. There's all kinds of patterns in there. There are all kinds of interesting questions in there, right?
Yeah.
Yeah. So, will you remind me next time to show you that, you know, Boolean, the world of, just like there are infinities and difficult things in the world of numbers, the world of Boolean also has many complicated things, right?
Excuse me.
Yes.
You told that you will be discussing about the Fibonacci sequence.
Yes. So you can see, Janvi, I'm trying to get there, but we have to go step by step, I guess, right? So I will get there. Probably not the next class, but maybe the one after that, right? The next class will continue. Yeah, but definitely I want to do that. Yes, so there are the Fibonacci sequence is an example of a nice pattern that we find in nature that we can represent very easily with mathematics. And so we can use it to create a lot of patterns, to understand a lot of patterns. And it also embodies some interesting ideas from computer science, right? So beautiful. Yeah.
I've done the Fibonacci sequence before.
Okay, what did you do with it?
So I did it I wrote a Python code for it and it worked out.
Good. So you just generated the Fibonacci number?
Yeah.
Yeah. So we will do that. We will easily write the Python code for it. And then we will ask some interesting questions about Fibonacci numbers and use it also. We can use it for drawing and so on and so forth, right? So there's a lot of good uses. But I want to tell all of you that Fibonacci is only one example of millions of patterns that are out there, right? So this opens the door to lots of interesting questions. Okay, one last question. People are like, okay, we're done. Anyone?
Why is Fibonacci so important?
Why is it important? Okay, so then maybe, okay, let me give the short answer, and then when we discuss it, we'll discuss the long answer. For those who don't know what Fibonacci sequence is, it's a very simple thing. It basically takes a number, two numbers. So like you start with 1, 1 plus 1 is 2. Then you take 2 and 1, 2 plus 1 is 3. You take 3 and 2, 3 plus 2 is 5. So every time you take the previous two numbers and add them, you get a new number. So it's a very simple sequence, right? But that simple sequence, maybe because of its simplicity, is found in many places in nature. And when we try to do things, for example, when we try to understand percussion rhythms in music, there's some very interesting ways in which you can combine musical beats to make rhythms. And many of them follow Fibonacci type patterns. But it's also there in the arrangement of flower patterns, in the shape of the shells on snails and various things. So you can get like hyper excited about Fibonacci, right? But what I want to tell you is we will get excited about it, but we also realize there are other patterns too, right? So it's not that it's everything, it's just one of the interesting patterns. The other thing which is very cool with this particular Fibonacci pattern is it's very simple. In order to write code, in fact, you can start writing this code if you want. You have to take basically, but you have to start from 1 and build it up. So if you give me 2 Fibonacci numbers, then the new Fibonacci numbers, just add them, that's it. Right? So not so hard to create. So it's a simple pattern, but it's useful in many places. So we'll discuss it. I'll show you how, I'm sure some of you are curious, how does it connect to music, for example? But we'll do it, okay? Okay, now I really don't want to hold all of you anymore.
Wait,
Yes.
last thing.
Yes, yes, of course.
When you say we have to make the code to write the Fibonacci sequence, like what do you mean? Like which term? Like it's gonna be infinity. Like it would never stop. Like it just keep on adding on.
Yeah, it does not that it never stops. So for example, if you look at flower petals, you might find that in the innermost circle of a flower, you find 3 petals. Then at the next line, you find 5 petals, right? And you notice 3 is a Fibonacci number, 5 is a Fibonacci number, and so on, right? So you at each layer, you count the petals and you say, hey, these are all falling as Fibonacci numbers. But it doesn't go to infinite because the flower is only fixed size, right? And only so many layers of petals. Does that answer your question?
Yeah, but like I was saying, like when you write the code, but it's like will you write it like for some specific thing, like for example, like pineapples or something?
Yeah. So you'll find it in various places, right? You'll find it in various places. So we'll spend more time on it. It's very fascinating thing, though. I have to say. Okay, I am happy to stay and chat with all of you, but I'm sure some of you also want to go and have your lunch or dinner or get to bed. So I don't want to hold you for too long. So I'll let all of you go. May I continue that beautiful work you're doing with writing your code, and little by little during the week, do write. I will also try to make sure that I respond as quickly as possible. Okay. I'm sorry I was so overwhelmed by all of your responses, but okay, I think I've caught up now. So we'll see. So I'll let all of you go. Keep up the good work, and we'll talk soon.
Okay.
Bye. Thanks for the class.
Bye. You're welcome.
Thank you.
Have a nice day or
Thank you, sir.
night, whatever. Thank you.
Thank
Bye.
you.